Um, yeah, so we are going to talk about timber construction systems, and we divided construction with wood into three categories: skeleton frame construction systems, frame construction systems, and solid timber construction systems.
And we also have separated these topics. Every topic can be separated in a prefabrication and also on-site construction. And the skeleton frame in an historical and engineer skeleton frame. The frame construction with the North American balloon and platform frame, and the European frame construction. And solid timber construction systems also can be separated in some more different types we will mention later.
Yeah. Starting off with skeleton frame construction systems, we're going to talk briefly about historical timber framing. This is a construction system typical in Germany, in northern Germany. It's an on-site construction system. The reinforcement takes place via panels, diagonal struts, crossovers, and head straps, and the windows are built within the construction grid. Continuing with engineering-wise skeleton structure, this system has a variable grid or module, high degree of prefabrication, load-bearing skeleton is independent of the room enclosing walls, span width is larger than the other construction methods. We can divide engineering-wise skeleton structure also in categories. For example, post and beam construction. This system has continuous columns, and the columns and beams are in the same axis. Beam on column. This system has continuous beams, free positioning of the columns, and the cantilevers are in the axis of the main beam possible. And also separated beams. This system has continuous beams and continuous columns. Cantilevers are possible in both directions. There are also separated column systems. Here's an example of separated beam constructions. It's the Tamega building in Zurich of Schöffmann architects from Schöffmann architects.
Okay, now we are going to continue with timber frame structures. The general facts are that the overall length of the building is not dependent on a multiple of an axis, so it can vary. And you can arrange the windows and the openings in the exterior and interior walls as you want. And the timber frame structures began in the 19th century in the US, and the main advantage is that you can build them very fast. They have a narrow construction grid, and there are basically two types of frame structures, which are the balloon frame, where you have wood stands run unjointed over the entire wall height, and then the platforms attached to that. And on the platform frame, or in the platform frame, you always build your platform, then the workers can work from there and build the next level. And they are all connected with nails, which is not so good if you want to use it again, so it's hard to reuse those woods. And the European timber frame structures are basically the same, but the dimensions of the pieces are a little bit bigger, and so the distances between those pieces can be a little bit wider. So but it's basically the same thing. Here is an example in Munich where you can see pretty good how those frames are built. And we are moving on to the timber panel construction. Those are prefabricated elements and pretty much like the frame structure, but the difference is that it's not on site, and there are insulation in those elements, and the openings are pre-cut, so they will be transported to the building site, and there they only will be built up. There is a timber panel construction. So the log structures, they are also historical, I would say, especially here in the Alps region. And it is a construction predominantly from horizontal woods. As you can see in the image, those pieces are connected together by interlocking. And the negative side is that you cannot have so much openings, and due to the characteristics of the wood and the loads, there is a movement after the construction from 2 to 4 centimeters per floor. So it's a lot of movement, and you have to consider that to have flexibility for the openings, like windows, that they don't break. And nowadays there are also variations from the industry to have panels for this type of construction with multi-layers and insulation. Another solid timber construction system are the board pile and dowel systems, which are basically the boards are nailed together, or they are put together by dowels. When you're nailing this, the disadvantage is that you cannot have exact measurements, and due to that you have to use it only for secondary purposes. But if you're using dowels, it can cut very precisely, and it can also be a load-bearing wall or to very clear geometry. So then the cross-laminated timber, which is a very good construction method, because wood is better in some directions of its what's the word? Well, wood works better in the direction of the tree growing. So due to the cross-lamination of the single pieces, those characteristics, negative characteristics in the other side vanish, and you basically eliminate the disadvantages of a wood structure. And it's better because there's less movement due to the water loss. And yeah, it's basic. It's also very good because you don't need to have a grid. You're very free to make your floor plans, and they can also be load bearing in any building elements. And due to modern technology, you can also cut the elements very precisely. Here we can see some pictures from a building site, and on the right side there is an example for a building element with installations integrated, which is also possible. Here another example in Milan, and the space models we won't cover now because we already
have them. Yeah. So there are also hybrid systems. timber with reinforced concrete, timber with steel constructions, and all of them combined. Here we have an example in Vienna. It's a building with timber and reinforced concrete structure combined. It's 84 meters high. And there are also more systems like top wall system and ligature systems. Yeah, thank you.